All right. Hello, everyone. I'm Ruthvik, and today with me we have my team members. That's Misrang, Gargi, and Mir. So today we're just going to be going through our project presentation. So the name of our project is Codelens AI. So it's an AI-powered repository tool with a grounded Q&A in place. So I'll just go over through the agenda of our presentation today. So we're going to go through the problem statement and motivation, the system overview, and the architecture of our project, the front end design, and then the most important thing, the AI techniques and integration. And we're going to move on to the workflows of how we're able to achieve what we're doing. And then we're going to look at some results and discuss a few key takeaways and our future work. So going to the problem statement. So modern code repositories are difficult to understand quickly, and that's especially new for uh, people who join, who are new contributors and reviewers. So developers often spend a significant time locating entry points, tracing feature implementation, understanding the architecture, and interpreting brand changes before they can contribute anything effectively. So in order to tackle this particular problem, we came up with a solution. So this solution, the real motivation behind this is to um, overcome this problem. So it was built to reduce this friction, and we do this through repository ingestion, guided summaries, grounded code question and answers, and branch level guidance. So this is what our motivation was to tackle our problem. So over to Mir now.
Yeah, hello. I'm gonna be explaining the high-level system architecture. The system is basically divided into four main parts. So first is the front end where the user interacts with the UI and uploads the repository and queries the dashboard and view the results. And then we have the back end based on fast APIs, which handles the API routing, logic, authentication logic, and request handling. And then the AI pipeline deals with the code chunking and embedding generation, semantic search, and AI response generation. And at the last, we have the data layer, which deals with the vector storage, repository indexes, and query history, and metadata storage for the repository. And let's go to the next slide. Yeah. So let me walk you through the workflow of our architecture. So the front end communicates with the back end using the APIs, and the back end deals with the authentication services and repository ingestions. And the user actually uploads the repository from the front end, and this repository will be the code of this repository will be divided into chunks, and these chunks will be used to generate embeddings, and these embeddings will be stored in the vector db along with the metadata of the repository. So whenever a user queries, the retriever will do a semantic search in the vector DB to find the most relevant code chunk. So it helps the LLM to generate the most accurate response for that query. So this is the workflow.
All right, so I'll go through the front end design. So this is how our landing page looks like. So it's a very clean front end design. So the front end mainly includes the authentication, the dashboard, the overview, the Q&A, and the branch guide. So you just try to keep the layout pretty minimal, trying to focus on the functionality much more. And so here we can have a look at our sign-in page, and this is the Q&A part wherein a user can input any type of query and ask the AI, and based on the repository, and you get the responses um, in this panel. So what it does, the responses go through the repository, it summarizes it into readable content, and then it gives relevant information. And the final image seen is the branch information guide. So it's a comparison between the current branch and another branch, for example, as to how far ahead a branch is working on. And it gives suggestions, for example, merging the front-end integration into the main branch after a review. So this is how the front-end UI looks. Over to the AI techniques.
So now if you go into AI techniques and integration, Codelens AI is built around a five-stage pipeline. First, the user adds a repository via GitHub URL or zip, in which we filter files by extension and size. Size. Those files go into a LangChain's recursive character text splitter, which chunks them into 1,000 character pieces with a 150 character overlap, so no context gets cut at a boundary. Each chunk is then embedded and they are run locally. And those vectors are stored in a FAIS SS index. And at query time, we search the index and pass the top results to Grok's Llama, which generates a grounded source backend answer. Now, if we go on the RAG pipeline, next slide, yeah. So now here's how a query actually flows through the system. The user question is embedded with the same model used at ingestion. This keeps the query and the index in the same vector space. Then the FAISS returns the top five chunks with relevant scores, and these chunks are assembled into a structured prompt, and Grok generates an answer for consistency and grounding. Then the source file reference comes back to the UI along with the answer. The design decisions on the right explain the why, and the 150 character overlap prevents context loss, which share and it share the shared embedding model guarantees semantic alignment, low temperature, and which keeps the LLM on task. And we built a fallback mode so that the system stays functional even without an LLM key configured. Now, if we go to the branch analysis follows a similar pattern. The user selects two branches. We extract the get difference and send it to the LLM with the JSON mode enabled. So then the output comes back as structured fields, summary, or key changes, and it recommends next steps. That's rendered directly as a branch analysis card in the React UI. The table on the right is the full stack in one view. All all the models are used for embeddings, and FAISS is used for the vector score. Llama is used via Grok is used for generation, and the fast and the 3JWT authenticated fast API is tying all the endpoints together.
Okay, here I'm explaining the integrated workflow between the front end, back end, and the storage layer. The React front end is where the user interacts with the app. When the user logs in, uploads a repo, asks a question, or runs branch analysis, the request goes to the fast API backend. The backend then routes that request to the correct service, that is authentication, repo processing, Q&A, and such. SQLite stores and authenticates records, while local storage keeps the repo files, indexes, metadata, and Q&A history. For generation, Grok and Open Router are optional. If those keys are not available, fallback mode keeps the Q&A flow usable. Next slide, please. Okay, this slide explains how we validate and run the system. Locally, the app runs as two services, the fast API backend on port 8000 and the wide frontend on port 5173. The frontend connects to the backend through the configured API-based URL. For validation, we check that the backend starts with UICon and white and health and docs are accessible uh, by the front end. We also have PyTest and for the automated test execution. Runtime behavior depends on configuration, that is SMTP enables OTP and password reset emails, LLM keys enable Grok or open router responses. Next slide. So this slide summarizes what we learned from building CodeLens AI and where the project can improve next. One major lesson is that the retrieval quality matters as much as the LLM itself. We also learned that the repo answers need to stay grounded in the actual code base. That is why source backed responses and file references are important for trust. For resilience, the filtering and fallback behavior were also important. The system needs to skip irrelevant files and still work even when the external element keys are unavailable. And we have to make it more robust support for private repositories.
All right then. So that has been our presentation. So now I'll just go through a demo of the actual project. This is our EMD file, and here we have our API key. And we tried two different approaches. One was using API, Open Router API, and the other one was through Grok. And this is how we are hosting the user authentication fallback. So let me just start the front end, the back end, right? And this is the front end. Right. So this is the dashboard that we have. I'll just log out. Yep. So here we can log into the application. I already have my password set up. So let me just sign in. Right. So a new user can definitely sign into the application using a new account. So this is how, as we mentioned, the landing pages. And right over here, we can see that we have our current repository, which is CodeLens, already loaded. So let me just open the repository right then. So we have a project purpose. So this is basically a small summary of how the project, of what the project is about. So it gives a small summary, and it includes four major details. One is the entry point. The second one is the important modules with respect to the actual functioning. Third one is probably the authentication area for this particular repository, and a recommended reading order. So this is an order in which any reviewer or anyone new who is actually going through the repository can have a look at. So this is the overview. And then in core Q&A, we can ask questions to the AI and figure out how the repository actually works. So let me just ask, yep, which files define the main front-end page layouts? And yep, so as we were using Grok as the main AI for this particular session, the response mode is Grok. So the main front-end page layouts are defined in the actual component, which serves as a wrapper. And it gives the most important file citations, meaning the actual files from wherein the answer came through. And it lists the same files so that any developer can actually go through and figure out the code for himself. We also have a scoring in place wherein higher the score, most likely that the particular component is available in that file. So we can ask any other follow-up question. For example, how does the actual core Q&A work? It's contracted around doc handoffs and all of that. And then it gives the actual files wherein it's actually working from. We can add a new repository. So you can go to the repository dashboard, add a repository. So I have an app on my desktop. So we have two different types of approaches to add a new repository. One is to either a GitHub URL or a zip archive. So let me just choose, yep, this app, add repository. All right. So the repository loads up here. And this app was built on SwiftUI. So it is actually an app that can be used as a daily tracker of sorts, a daily management. So does the app have let's say, a settings menu? Right, it does have a settings menu.